Hi students, this is the lecture on PH 3501 Unit 1 Solid State Physics. In the topic number 7, that is the crystal symmetry. Till the date we have seen what it means by crystal, thereafter we have seen what are the varieties of crystal, thereafter we have seen what are the further category of the 7 crystals, and that is a brevis lattice, and that is 14 varieties of a brevis lattice on the basis of alpha, beta and gamma, A, B and C, that is 6 lattice parameter. So, in the next topic, that is a symmetry. The first question arises, what it mean by symmetry? Symmetry is what it mean by crystal symmetry. So, symmetry, that means when you do some kind of operation on a crystal, it should not be noticed by observer that the operation, before the operation and after the operation, it should remain invariant. That means if you applied any kind of a operation, or let us say job on the crystal, you will find that or rather you are not able to distinguish the first situation and the second situation. As for example, you have a dice which you use in your normal games like snake and ladders. Let us assume that dice that is without number, and if you rotate the dice with a 90-degree, you cannot find whether the die is rotate by 90-degree or not. In short, when you do any kind of operation on your cubic setup, and if you rotate by 90-degree, you may not able to distinguish the first situation and the second situation because that looks like exactly identical. And therefore we can say that if a cubic crystal is rotated by 90-degree with one of the particular axis, then we cannot find the crystal and its environment is changed, or we can say that they are remain invariant, and such situations are referred as a symmetry operations. Now this symmetry operation having a principally two kind of types. One is said to be a point symmetry, another is said to be a space symmetry. What it mean by point symmetry? Point symmetry is the word which tell us that any operations, as I said, rotation or something like that, so any operation, may be a translation, may be a rotational, may be a inversion, such kind of operations when you applied about a point, माने क्रिस्टल में कोई एक पॉइंट को ध्यान में रख के आप डिफरेंट काइंड ऑफ ऑपरेशंस अप्लाइड कर रहे हो. So when you applied any kind of operation on your crystalline system with reference to a point or maybe a line is called a point group symmetry, is called point group symmetry when you do some operation on this particular about a point within a crystal. And suppose you are adding a point operation along with a translation also. That means suppose you are giving some rotational phenomena as well as the translation within your crystalline system. That means you are displacing from a point. Now you are not be specified to a point, but now you are also moving within a crystal. So if there is a translation along with rotational or inversion or reflection kind of operations are combined, then such is known as the space group, okay, and or the space group symmetry. So Now we are knowing that there is a two kind of symmetry. One is a point symmetry, and point symmetry is made of this three kind of varieties of symmetries. So that's why it's known as a point group. It's a group of these three. Which are those three? One of those three operations is a center of symmetry, or is also sometimes known as a inversion centers. Secondly is a reflection symmetry, and third one is the rotation symmetry. So point स्पेस ग्रुप में तीन तरह के ऑपरेशंस क्रिस्टलाइन स्ट्रक्चर पे किए जाते हैं. एक इन्वर्जन, दूसरा रिफ्लेक्शन, तीसरा रोटेशन. और हर कोई ऑपरेशन में अगर सिस्टम इज रेफरेंस टू एनवायरनमेंट और environment reference to system is remain invariant, then it is called the point group symmetry. ठीक है. और एक एग्जाम्पल दिया गया है, that is called the center of inversion. Suppose you have a cubic setup, cubic crystalline system. In center of that you are choosing a point or an atom. Let us say it's a body center. So one atom is at center. Now this atom is looking to this corner, and that is at a distance r. Suppose I assume that this atom is doing the inversion of a 180 degree. So यहाँ से आप एटम को उठाओगे और उसको इन्वर्ट करके पलटी मार के यहाँ पे ला सकते हो. So it's the entire diagonal. So half of the diagonal you have a one atom at a center, another atom over here. जैसे यहाँ पे आपको दिख रहा है, वही सिचुएशन जब 180 इन्वर्जर करोगे तो यहाँ पे दिखाई देगी. दैट मीन्स यहाँ पे एटम होना, वन ऑफ द वर्टेक्स ऑफ द अपर प्लेन हैविंग अ वन ऑफ द एटम, बॉटम वर्टेक्स पे भी एक एटम होना. सो इट लुक्स लाइक अ इन्वर्जन सिमेट्री. Same way you can having the another body diagonal, and you can also have the same phenomena. So over here in this example of a point space group symmetry, we are discussing the center of inversion or a center of symmetry. Center of symmetry हर कोई क्रिस्टल के लिए लागू पड़ता है. हर कोई crystalline setup में center of symmetry is always going to be observed, especially in the all cubic setup. You have 100% center of symmetry is always available. The next one was the reflection operation. Reflection symmetry, that means you have to assume like a one mirror you are inserting in your system. Let us assume that this is your x-axis. So let me write here x. Let us say this is your y-axis. Let me write here a y, and this one is the z-axis. So one can understand what is the x, y and z. Now exactly in half of your x-axis you are drawing a one plane, or you can assume that there is this plane which is parallel to the yz plane, which is intersecting the x-axis. The plane which is parallel to the yz, so that is the shaded plane which is intersecting the x-axis. उसी तरह आप एक दूसरा प्लेन सोच सकते हो which is parallel to the zx plane, so that is this one, and which is cutting to the y axis. Y axis यहाँ पे है तो ये यहाँ पे y axis को काट रहा है. Similarly this is the z plane, so this is intersecting the z axis exactly at a half. So reflection, so basically The motive is, suppose you are putting a mirror within your cubic crystal. So within the mirror you are finding the depth, right? So यहाँ आप हाफ ऑफ द विड्थ ऑफ द क्यूबिक सेटअप पे आप एक मिरर की वॉल जनरेट कर रहे हो, प्लेन बना रहे हो. So within a mirror you are finding the exactly similar depth. So the back portion of your mirror you are getting inside the mirror. That means reflection of your front portion of your cube you can see within your cube, within the mirror, and therefore it is a reflection of your first part which is exactly similar which is on the back side of the mirror, and that's why it is known as a mirror reflection. यहाँ पे भी आप देख सकते हो कि y along y एक्सिस को मैंने हाफ लेवल पे कट किया. सो फ्रंट क्यूबिक पोर्शन ऑफ द imaginary plane it is exactly identical to the plane which is back side of it, and similarly for the z axis. So reflection symmetry is nothing but you have to visualize a plane made up of a mirror which give you the exact identical structure which is in front of you, which is in front of the mirror, which is in the front of the plane, which exactly mimic the structure which is backside of the reflecting plane. So that is called a reflection symmetry. So यहाँ पे आप तीन तरह के रिफ्लेक्शन सिमेट्री सोच सकते हो. एक जो एक एक्सिस को कट कर रहा है, दूसरा जो y एक्सिस को कट रहा है, तीसरा जो z एक्सिस को कर रहा है. दिस इज कॉल्ड द रोटेशनल सिमेट्री. इसके पहले वाली स्लाइड में हमने देखा कि वी कैन हैविंग ऑल्सो हैव द center of symmetry. So this is only one, but over here you having a three varieties of a reflection. So if I will make a list of symmetries available in a cubic crystal, then very first one is center of inversion symmetry or center of symmetry, which is referred as which is with the quantity 1. But when the second operation what we have underlined in this point group symmetry, that is reflection symmetry, and here I am finding the three varieties of a reflection symmetries: the plane which is cutting the x, the plane which is cutting the y, the plane which is cutting the z axis. Okay, let's go to the next point. And what I have observed that there is a one more kind of a reflection symmetry is possible, and that is rotational. But before start the rotational symmetry, let me touch the another reflection symmetries. The earlier one we have seen the three reflection planes which are cutting or lying in a पैरेलल टू द अदर टू कोऑर्डिनेट एक्सेस. माने एक्स एक्सेस को कट करने वाला प्लेन वाई जेड को पैरेलल होता है, वाई एक्सेस को कट करने वाला प्लेन जेड एक्स को पैरेलल होता है, राइट. यू हैव सीन इन योर प्रीवियस स्लाइड. लेट मी शो इट यू अगेन. सो दिस इज द प्लेन which is lying in the yz, and therefore it is able to cut the x axis. But anyway, the motive to discuss the same one is, in addition to this reflection three planes, we having a 6 diagonal planes. One diagonal planes which is lying in the, let us say this is x, this is y, and this is z. Let me draw it for you. So let us say this is x, and let me write for you. Let us say this is x. The another one is, let us say, y, and the last one is z. So if I will select This is the z axis. And that is your z axis. Okay. So this plane is talking about the very first one. This is lying in the xy plane, which is passing through the xy plane and parallel to the z axis. This plane is again parallel to z axis. So plane number 1 and plane number 2, if you look at, it is passing through the diagonal of the face xy. xy माने नीचे वाला प्लेन. नीचे वाले प्लेन की वन डायगोनल पे ये प्लेन आता है या तो ये दूसरी डायगोनल पे आता है. Similarly, this plane and this plane, I repeat, this plane and this plane, if you look at minutely, this plane are lying from, this is your x axis, this is your y axis, and this is your z axis. So it is coming parallel to the x axis. This plane is parallel to the x axis, and therefore such kind of a two diagonal planes. And same way, these are the two diagonal planes which are parallel to the y axis. So this plane is cutting the z and as well as cutting the x axis, but it is do parallel with your y axis. So this is lying in the zx plane. Okay. So 6 diagonal planes are there and 3 straight planes are there. The third symmetry what we had discussed, that was a rotational symmetry, and that rotational symmetry may be defined like this, where 360 divided by n, where n is referred by the fold. Please remember, n is referred by the fold, and this fold will give you the rotation about the one point or a center of the point of your crystalline system. So if I will make a list, then a 1 is a center of symmetry, then I do have a 9 plane symmetry. What are those? 3 straight planes which are cutting the axis individually, and 6 are the diagonal planes. So kul mila ke 9 plane symmetry, 9 mirror plane symmetry. Then there is a list of a 3, 4 and 6. I had written something for you, that is called a perpendicular to the plane, the body diagonal and the face diagonal. The figures are given in the book, and the tetrad axis which is perpendicular to the face. So any 3 faces, cube is made up of 6 faces, and 2 faces are always parallel to each other, and therefore any axis which is passing through a 2 parallel planes, then such 3 axes are possible perpendicular to the plane. And if you rotate a cubic crystal across that 3 axes, it remain invariant. That means you are finding in a certain rotation, you are finding a rotational symmetry. Tried axis, that means it should be passing through the body diagonal. So if you think about a cubic setup, then a body diagonal, that means one corner to the down corner and one upper corner to the another bottom down corner. So that is a 4 corner on top and 4 corner on the bottom. So each corner diagonally if connected, so I may having a 4 body diagonal, I may have a 4 body diagonal axis. And the last one is the dyad axis. Dyad axis is the axis of a rotation which are lying at a center of the edge. Now our cubic system is made up of 6 faces. That means we do have a 6 edges parallel to the 3 edges at the bottom and 3 edges at the top, and therefore this 6 edges gives us the freedom to pass the 6 face diagonal. So basically this is lying in a one of your plane, maybe in a xy plane, then 2 axes are in the yz plane and 2 axes in the zx plane. So in all there is a 6 diagonal planes, diagonal, that is the face diagonals. So if you make a summation of this, all these possible symmetries, so that is 1 plus 9 plus 13, so that gives us the 23 rotational symmetry. So in nutshell, a cubic setup or cubic structure does having a 23 number of symmetries. This is the highest number of symmetry which pertain to the cubic crystalline system, and perhaps that's why the author has taken the concept over here. Next to this is very interesting that this 3 fundamental point group symmetry, that is the center of symmetry, then reflection symmetry, and then the rotational symmetry. So the different symmetry elements like center of inversion, reflection and the rotations can be combined. अगर मैं उसको combine करूँ, माने inversion के साथ reflection को, या तो inversion के साथ rotation को, या तो reflection के साथ rotation को, then I may able to generate some around 32 kind of a combinations which are different to each other, and therefore such kind of a 32 combinations are possible within your crystalline system. So in nutshell, there is a 32 compatible combinations in a point group symmetries. It could be your short questions, so try to remember this information in the back of your mind, and that is what a point group system or a point group symmetry. Now let us having an example, that rotation with the inversion. As I said, we having the 3 fundamental point group symmetries. Number 1 is the inversion symmetry, center of inversion symmetry. The second one is a reflection symmetry. The third one is the rotational symmetry. So out of these 3, I am combining the rotation and the inversion. Just look at the figure over here, and I try to explain you the figure. Let us say you are starting with the position number 1. You rotating your cube by 90 degree. So one of your face is right now over here on a position 1. Now you will be rotate your dice by 90 degrees. So now you are on somewhere position of the 4. So this dotted line is representing 90 degree of inversion. 90 degree of rotation. And now you are taking an inversion with respect to the center point. So 4 is switch over to the point number 2. So you are visualizing that I am doing the inversion of this position with respect to the second left arm, the right arm position with the left arm position. So 4th position I am visualizing at the 2nd position. So with a 1 rotation of a 90 degree and a inversion axis, I will be reaching from point 1 to point 2. Same way, if I will repeat this part, then point 2 having a 90 degree rotation, so I will be coming to the point number 3, and thereafter the inversion or the inversion axis allow me to go with the inversion, then point 3 will go to the point 1. So from where I have started, I will be coming back. So now you can understand that crystal can possess 1, 2, 3, 4 and 6 kind of a fold rotation, and same way you having a certain inversion axis. Inversion axis is shown by the bar, that is 1 bar, 2 bar, 3 bar, 4 bar and the 6 bars. So this is called one of your combination out of 32, that is a rotational inversion axis. Sometimes it's also called roto inversion axis. Now we are going one step ahead of that. That is a space group symmetry. What it mean by space group symmetry? When your any one of your point group symmetry is combined with a one of your any two point group symmetry you are combining here, and that is your giving you a freedom about the combinations of the point group symmetries only. But now you are going to the space group symmetry. In case of a space group symmetry, you are combining your translation symmetry with glide plane and the screw axis. What is glide plane? Glide plane is basically when a mirror plane, that is a reflection plane, is combined with a translation. So now remember, reflection plane is a point group symmetry, and translation is something else that you are adding to this one. So point group symmetry is combining now with a translation symmetry, and that gives us the स्पेस ग्रुप सिमेट्री. आई रिपीट, मैं फिर से रिपीट कर रहा हूँ, जब पॉइंट स्पेस ग्रुप सिमेट्री ट्रांसलेशन सिमेट्री के साथ मर्ज किया जाए और दोनों ऑपरेशन साथ में क्रिस्टलाइन स्ट्रक्चर पे एग्जीक्यूट किए जाए एंड स्टिल द क्रिस्टलाइन एंड द एनवायरनमेंट इज रिमेन इनवेरिएंट, then it is called a space group symmetry. Right now we are thinking about a mirror plane or the reflection plane with mirror plane with translation one. You can see a mirror plane with a translation symmetry, and that is gives us the glide plane. Now glide plane, where it is located? There are 5 varieties of a glide planes. Axial glide planes, which is cutting the particular axis. So if you do remember, there was a 3 reflection planes were there, which are cutting the exactly at a center of the axis, that is x, y and z. So similarly, the glide planes are always parallel to the reflection plane or the mirror plane, and therefore on the lattice axis A, B and C, at a half level of that, so half of the A, half of the B and half of the C, you can visualize a mirror plane. So you are traveling on x axis by half the way, so A by 2, and you are imaging a one mirror plane. So you have a translation as well as the reflection, so it is a glide plane, and that's why it's referred as a axis glide plane. Similarly, your B position is travel by B by 2, so that means again reflection B is visualizing at the position B by 2, and the similarly the C by 2. So there are the 3 axial glide plane. Similarly, you can think about the 2 diagonal glide plane, which is known by the N and D respectively. Now N is situated at A by 2 plus B by 2. So this diagonal plane you can visualize, it's a planes which is passing through any one of the plane like XY plane. So you having X coordinate and the Y coordinate. At the same time, it can cut the X axis and Y axis. It can cut the B and C axis or C and A axis. So same way in the fourth, 1/4. So A by 4 plus B by 4, comma B by 4 plus C by 4 or C by 4 plus A by 4. यहाँ पे और इसलिए दिया गया है, सो यू कैन हैविंग अ कॉम्बिनेशन लाइक A by 2 प्लस B by 2, या तो उसके साथ ये हो जाएगा ब्रैकेट, या तो उसके साथ लास्ट ब्रैकेट हो जाएगा. मान इन अ वे you have a diagonal planes, or since it's a translation plus reflection combined, so we are saying it's a glide plane as it is mentioned here. And since they are diagonally cutting the 2 planes, 2 axes, and therefore it's called the diagonal guides. And if it's a n, then it's situated by half the way. If it's a d glide plane, diagonal d glide plane, then it's situated at a 1 by 4, or let us say a by 4, or b by 4, or c by 4. I am sorry. And the last one is the screw axis, and screw axis, it is also referred by the hybrid roto inversion axis, where you are having a two kind of a operation. One is a rotational operation, roto inversion operation, as well as you having a translation operation. So rotational is coupled with translation parallel to the rotational axis will give you the screw axis. सो अगर आप एक स्क्रू सोच लो, तो स्क्रू को जब आप टाइटन अप करोगे या तो लूजन अप करोगे, तो स्क्रू की जो लेंथ है उसमें से जो पास होती हुई जो एक्सिस है वो तो या तो आगे बढ़ोगे या तो आप पीछे आओगे. इट्स डिपेंड ऑन योर टाइटन अप द स्क्रू और लूजन अप द स्क्रू, राइट. सो इट इज़ अ रोटेशन बिकॉज स्क्रू को आप टाइटन अप या तो लूजन अप करो, सो यू आर रोटेटिंग दैट वन, एज वेल एज स्क्रू या तो आगे मूव हो रहा है या तो पीछे मूव होगा, and that is where there is a translation. So when you having a rotation as well as merge with the translation, it is called the parallel to the screw, that is that axis is referred as a screw axis. So अगर यहाँ मैं चूज़ कर लूँ तो ये एक एक्सिस है, ये एक एक्सिस है, और मैं रोटेशन है उसको मैं एक्स वाई प्लेन में दे रहा हूँ, then my translation will be taken place along the z axis. Okay. सो स्क्रू एक्सिस इज़ लाइंग ओवर हियर. अब मैं इसको क्रिस्टलोग्राफी में इसकी लिखने की एक टिपिकल स्टाइल है. किसकी? स्क्रू एक्सिस की. सो स्क्रू एक्सिस विल बी रिटन लाइक बिग, आई मीन स्मॉल एन कैरेक्टर सफिक्स एम कैरेक्टर, एन सफिक्स एम, वेयर एन इज रिफर्ड बाय अ फोल्ड और द रोटेशन एंड एम इज रिफर्ड बाय अ ट्रांसलेशन. The fold will be identified by writing a 2 pi by upon n. What is 2 pi? 2 pi is a 360 degree. Pi is equal to 180 degree. So 2 pi radian divided by the n. So if I will understand in a degree, then 2 pi is a 360 degree divided by n. Let us say n is as the example has given over here. So n is equal to, let us say it's a m by n. So n is equal to 4. सो अगर मैं यहाँ पे n इज इक्वल टू 4 रखूँगा, सो 360 डिवाइड बाई 4, सो आई विल हैविंग अ 90, एंड दैट्स वाई दिस इज वन एक्सिस, b is the another axis. So the 7 character I am visualizing over here. If I am rotating that 7 character by 90 degree, it will come in this shape. Okay, so you are moving with a angular displacement phi from position A to position B, from position lattice axis A to the lattice axis B, and during this rotation screw is going inside the z axis parallel to the z axis. So वो कितना ट्रैवल कर रहा है? What is your translation part of it? So screw axis में translation part is written as m upon n. n is your fold, m is your traveling distance in the crystalline system. So that would be written by, in a square bracket, m upon n. In a square bracket 2 pi by upon n, that will give you the information about rotation. M by n we will giving a information about the translation. So let us say we having a 90 degree. So n is equal to get the 90 degree out of this particular square bracket, so 360 divided by what I will take, so it will give me the 90. So the n answer is equal to 4. So I am writing here 4. Okay, and secondly, this is answer is 4. And secondly, if you look at here, the 2 is your translation information. How it is appeared? So as it is say, I am thinking of 4 suffix 2, 4 suffix 2, that is m n m. n कितना मिला मुझे यहाँ से? 4. So because it's a 360 divided by 4, so it will give me 90 degree. So from lattice length A to lattice length B अगर मुझे जाऊँगा या तो x axis to y axis move होगा, then there will be a rotation of 90 degrees needed. So to achieve 90 degree I should divided by 2 pi divided by 4. Okay, point number 2. How shall I get the translation? Translation in a square bracket m upon n. So what is m? M is a 2. What is n? N is a 4. So basically it's a 1/2. Okay, now what it mean by this? So it is traveling a 1/2 times translation vector parallel to the rotational axis. Okay, so remember that in case of a screw axis, your rotational and your translation axis are parallel. So such kind of there is a 11 varieties of screw axis, and this all 11 screw axis are given here. And let us understand that how exactly this 11 axis looks like. So let me repeat again before jumping to the picture of the 11 screw axis. So the point group symmetry, when they are combining with the translation symmetry, they are called as a space group. और अगर ये सभी तीनों points group symmetry, that is a center of inversion, reflection symmetry and the rotational symmetry, these three symmetries are combined with all translation symmetry, and such kind of the in all 230 space groups are possible to be formed. That means in this universe, till the date research of a solid state physics, we may not have more than 230 varieties of a crystalline setup or crystalline symmetries. Okay, and this all the all the 11 axes looks like this one. So remember this is 2, 3, 4 only, there is no suffix because suffix portion is 0. Then this is 2 suffix 1. When I say 2 suffix 0, so the previous one where you had mentioned how translation symmetry is going to be written, that is n suffix m, n suffix m, or you can think about m upon n, that is your way of writing out the translation. 2 pi upon n, that is way of your writing out about the rotation. So n suffix m will give me the information about the screw axis. So let us repeat again over here. So if it's a 2 suffix 1, so 1 is my m, 2 is my n. When I having a 2 fold, so my outcome will come 180 degree. 180 degree is shown by the ellipse symbol. If you look at on the top of this, it's a elliptical symbol. So अगर ये 7 यहाँ पे है तो उसको 180 डिग्री पे मैं रोटेट करूँ, so it again looks like the same setup. So अगर ये कुछ वेरी ही नहीं हुआ है ऐसा लग रहा है, it is invariant. You can look at here, and we travels a full distance, that is a 0 position to the unit vector a, so or the unit vector z. So that is your t distances you have traveled. Now when you having a n is equal to 1 and m is equal to 1 and n is equal to 2, then translation will be written as 1 by 2. That means when you traveling a rotation, the same rotation 180 degree, you travel up to only half, and thereafter second half you are again traveling to the 7. So this 180 rotation will give you a symbol like the ellipse, but the tip of the ellipse is with the little bit notch. Thereafter this is a complete triangle. So here a complete ellipse, here a complete triangle, where you having the rotation of 20 degree. So 12 3s are 360. So there is a fold will be 3. Now in this 3 you having a 3 varieties. So 3 0, 3 suffix 1, 3 suffix 2. If there is a 4, then you having a 4 varieties, 4 0, 4 1, 4 2, 4 3, and similarly in the last, that is your 6 0, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. 6 5 is not available. Why 5 fold is not possible, we will see in the next lecture, maybe after few hours. I am so sorry that you need to have a little bit burden to wind up all the lectures in a one day. So anyway, try to remember this all 7 symmetries. In exam I may ask you what it mean by 3 suffix 1. I may give you the any one of your figure and you have to speculate, you have to write it out, their space group or the screw axis notation. So it could be 4 suffix 3. Then if I will give you a symbol like this, you should be in position to understand what it is. Okay, so or even if I will write what it mean by 4 suffix 2, you should be in a capacity to understand what is n, what is m value, what is a translation, what is a rotation. Okay, so with this I am stopping here. Stay home, stay safe, good luck.